Assalamualaikum warahmatullahi wabarakatuh and hi, my name is Syafiqah Izwani binti Hazaman from group K2. So today I'm going to discuss about the strategies to control the nutritional changes in frozen vegetables. A vegetable is a fresh edible herbaceous plant that can be eaten, either cooked or raw. Edible parts of vegetables include roots, stems, flowers, fruit, seed or leaves and leaf stalks. As we know, vegetables provide important nutrients such as vitamins, minerals, and antioxidants that is good for our health. So, freezing technique has been widely used to preserve vegetables in the long term. This technique involves changes in substance physically by changing cellular water into ice due to the removal of energy in the form of cooling below freezing temperature. So, firstly, we're gonna talk about the mechanism of freezing. So there is an illustration on the freezing of cellular plant. So firstly, the cellular plant will go through pre-cooling. Pre-cooling is the liquid contained in the cell that is cooled starting from initial temperature until it reaches the initial freezing point and sensible heat is removed. During a phase change, latent heat is removed and ice forms at the extracellular space. Then, the concentration of solute in the intracellular space will increase. This also will create the differences of osmotic pressure between intracellular and extracellular that will result in water diffusion across membrane cell. And also, it will form crystals at the extracellular space. Once there are no interfaces between frozen and unfrozen, the temperature will fall freely and release the latent heat from the ice surface. Lastly, during the subcooling phase, further cooling is proceeded to maintain the ice equilibrium with the external environment or storage temperature. Before we go to the strategies to control the nutritional changes, firstly we need to know what are the changes occur between fresh vegetables and frozen vegetables. So, fresh vegetables that did not undergo any processing after harvest or during post-harvest, it will likely to have water loss. Since vegetables have a high internal relative humidity, water vapor will move from high vapor pressure to low vapor pressure. Next is enzymatic reaction. The changes in enzymatic reaction may be in terms of respiration, color changes, ethylene production, and compositional changes. Basically, at temperature above 30 degrees Celsius, metabolism becomes abnormal and may produce rapid deterioration. Microbial growth also inhibited due to temperature abuse or presence of damage to vegetable cell. For frozen vegetables or vegetables that undergo freezing process, the nutritional changes may be in terms of textural change. During freezing and thawing, firmness and crispness will decrease and rupture stain increase due to formation of crystal. It also will change in color, flavor, and vitamin. For example, the green color is lost by degradation of chlorophyll. During storage, chlorophyll is converted to pheophytin with a loss of green color and vitamin C due to storage temperature and time, acidity, and blanching time. So, next is the microbial growth. Some organisms in the frozen state will likely to survive and grow when vegetable is stored. These are the strategies to control the nutritional changes in frozen vegetables. So we can control it either before freezing, during freezing, or after freezing. Before freezing, we can do the high pressure steam blanching. It is the pre-treatment used to disrupt enzyme activity. So next we do is dipping. For example, ascorbic acid and sugar solution is used to minimize browning. Next pre-treatment is we glaze the vegetable. This is act as coating against oxidation and moisture loss. So boil in bag and stand-up pouches is one of the packaging type before we freeze the vegetable. During freezing, we can do the cryomechanical freezing, which involves in immersion in the liquid nitrogen to form a protective crust. This is suitable for vegetable preservation due to its high moisture content. This method is good to reduce refrigeration loads and packaging, storage, and distribution costs and provides a comparable quality. After freezing, thawing is one of the essential steps. We can thaw the vegetable either in microwave, cooking, or thaw inside a refrigerator. But thermal processing in microwave is better to disrupt microbiome and maintaining sensory attributes compared to thawing inside a refrigerator. Overall, freezing is one of the widely and successfully method used to preserve vegetables. By understanding the mechanism and nutritional changes during freezing, there are pros and also cons in several processes. Thus, various strategies can be applied to treat and reduce the nutritional changes as well as maintaining the safety of the products in a longer period. So, thank you. That's all from me.